Good morning and welcome you all to this session of the course. Now we will try to solve some problem. Okay. Now here it is. Okay. Now let us see a problem now. Okay. Okay. Here also I did a mistake. This will be not, this will be a repetition of this. This will be n, this will be m, we are writing n by root over T1t, and this will be for T3t by T1t. This I did a mistake earlier, this will be like this, the two curves. Okay. Now let us solve a problem. So we have discussed the principle of the characteristic curves, the concept of surge, the surge line, the maximum efficiency line and the choking line. Now let us consider this problem. A centrifugal compressor has an impeller tip speed 360 meter per second. This is the impeller tip speed. Determine absolute Mach number of flow leaving the radial vanes of the impeller and the mass flow rate. The following data are given. So data are given. So let us see that Mach number of flow leaving the radial vanes. Absolute Mach number means based on absolute velocity. If we recall the vane, now let me recall the vane like this. Sorry, this is the vane. It is not, oh, then this is the vane. Okay, this is the vane. Now, if this is the vane, then what is the diagram, that the velocity diagram? Let me better show these things which I earlier shown you. Yes, this is the thing. I think this will be better to show like this. We can make things like this. Can you see? Okay. Please. Why I am writing that, why I am not doing the radial one? Here one thing is important, that slip factor is given 0.9. That means here due to this slip what happens? We have a, this is the rotating in this direction, U2. So VR2 is not radial because there is a slip. So VW2, this is VW2, VW2, and VW2 is less than U2. What is U2? U2 is this one. Okay, this is U2. So this is the absolute velocity V2, and this velocity is VF2. This is VF2. So this is the diagram because there is a slip. So therefore this is the outlet triangle. Now what I will do? I will write what has to be found out. That it has to be found out the Mach number based on absolute velocity at the outlet of the impeller. So therefore I have to find out Mach number V2 by root over gamma r T2. Okay. Now how to find out V2? V2 is the absolute velocity. Now V2 is root over, this is VF2, VF2 square plus this is VW2, VW2 square. Now VW2 is not U2. Okay, this is U2, this is U2. So VW2 is sigma U2. Okay, now U2 is 360 meter per second. VF2 is given flow area, power input factor, impeller tip speed, flow area, mass flow rate. So VF2 is not given, impeller tip speed is given, radial component of flow velocity is given. VF2 is 30 meter per second. You see that VF2 is 30 meter per second. So therefore you get V2 is equal to 30 square plus 0.9 into 360 square. I will not do everything, calculations square, and this way you will get a value of V2 equals to, what is the value of, let me tell you the value of V2 here. The value of V2 is 325, you can check, 325.38 meter per second. Now to find out the Mach number you require this static temperature. Here in the formula it is gamma R T2, T2 is the static temperature at the outlet of the main. Now, how to find out T2? Now, our main objective to find out T2. How to find out T2? Now, let us first find out the total temperature T2T. We know that T2T here, T2T is equal to T3T, that means outlet total temperature from the compressor at the outlet of the diffuser. And we know that Cp into T2T minus T1T, that is the work done, that is equal to psi sigma, that power input factor, U2 squared divided, this is okay. So, now here you see T1T is given, where? Because the inlet stagnation temperature 300 K is given, psi is given, power input factor is given, 1. Now, slip is given 0.9, sigma is given 0.9, psi 1, U2 is given 360 meter per second, T1T is given, the inlet stagnation temperature is 300 K. So, everything is given except T2T, from which we can find out T2T equals to what? T2T becomes equal to, ultimately if you calculate T2T will be 416 K. I am not writing every step because everything I know. Power input factor is given in the problem, slip factor is given in the problem, and T1T is given in the problem, U2 is given in the problem. Again I show you the problem, that impeller tip speed is 360 meter per second, radial component of flow velocity 30 meters, slip factor is 0.9, flow area at impeller exit is 0.1 square. It is not now required. Power input factor is given, isentropic efficiency given, inlet stagnation temperature, inlet stagnation pressure, then R and gamma. So, here what is required? Power input factor which is given as 1, the slip factor which is given as 0.9, U2 is 360 meter per second, and T1T is 300 K, we get T2T. Now, what happened? T2, how to find out T2? Now, T2 has to be found out from the concept of the stagnation temperature. What is that? T2 plus the temperature dynamic velocity equivalence, temperature equivalence of the dynamic head, that is V2 square by 2 Cp. That is the temperature equivalent of the kinetic energy, V2 square by 2. That is, this plus this is the total temperature, from which we can find out T2 is, T2T is now found out 416. Now, V2 already we have found out 325.38 meter per second. The value of Cp has to be found out from R and gamma, which you have read at school level, that the specific heat at constant pressure is gamma by gamma minus 1 into R. So, you know the Cp. So, therefore, from here you can find out the static temperature as 363.33 K. Everything is known. So, we know the static temperature. When we substitute the static temperature here, we get the Mach number equals to the Mach number 2, for example, the 2 suffix I am using equals to 0.85. All right. Now, the next is the to find out the mass flow rate. How to find out the mass flow rate? You see the mass flow rate. Let me keep it here so that you can see it. Now, mass flow rate, to find out mass flow rate, let us write the mass flow rate. Mass flow rate is same throughout the machine. Let us write the mass flow rate based on the condition at the outlet of the diffuser, rho 2, the A2 and the flow velocity. Now, here A2 is the flow area at the outlet of the impeller, which is given, you see here, flow area is given, radial component of flow velocity, the mass flow rate, impeller tip speed, flow area at impeller exit. That means A2 is already given 0.1 meter square. So, what is not given? Vf2 is given, the radial flow velocity component that impeller exit is given, Vf2 is given, Vf2 is what? 30 meter per second. It is all right, 30 meter per second. What is not given? Rho 2. So, how to calculate rho 2? Now, rho 2 is P2 by R T2. Now, T2 I know the static temperature already, T2 already is calculated here. So I don't know P2. How to calculate P2? Now before calculating P2, you have to calculate the stagnation pressure. Then if you calculate the stagnation pressure, then you can calculate the static pressure. So how to calculate the stagnation pressure? So stagnation pressure you can calculate P2 by P1T from your this earlier formula 1 plus eta C into, you can write like that, T2T minus T1T divided by T1T to the power, this has been told earlier, gamma by gamma minus 1. So you remember this one, that is the pressure. This comes from where? This comes from the isentropic relationship, and then using the isentropic efficiency of the compression. Well, so using this relationship we can find out. This relationship, if you remember, this was derived in the class. That means I find out this way, that if these are the two pressure lines, then what happens? This P2T, P1T, then this is the thing. This is the T2T, T1T, and this is the T2T dash. So P2T by P1T is T2T dash by T1T to the power gamma by gamma minus 1. Now this T2T dash T1T is found out by expressing this eta C is T2T dash minus T1T. I repeat again, this was done earlier, minus T1T. So therefore T2T dash, that means P2T by P1T is T2T dash by T1T to the power, this is the isentropic relationship, PT relationship. So this thing is taken from here, T2T dash by T1T is eta C into this plus 1. So eta C into this by T1T plus 1. So therefore we can write this. This is the thing done earlier. Now T2T minus T1T, you know, already you know T2T, you already know T2T. T2T is find out, T2T is 416K. You know T1T, T1T is 300K given. Eta C is given in the problem. Eta C is what? Eta C is 0.9. So therefore T1T is known, everything is known, you find out the P2T. Now after knowing the P2T, you have to know the P2, because how? Because rho 2 is P2 by RT2. I wrote it earlier, RT2. So you have to know the static pressure. Now how to know the static pressure? By the concept of stagnation pressure. P2 by P2T is T2 by T2T to the power gamma by, where from it comes? That means the static pressure is changed to stagnation pressure. That means when this is brought rest isentropically. That means this process of changing from P2 to P2T is obtained by bringing the fluid isentropically to rest. That means therefore the gain in temperature T2T from T2 is made isentropically, so that the pressure ratio will be related to the isentropic relationship with the temperature ratio. This is the relationship between total or stagnation pressure to the static pressure. So therefore T2, T2T is known, therefore we get P2. So we can find out P2. You understand? So from here we find out P2T, P2T is known, here we find out P2T, P2T is found out here, and here we find out P2, because P2T is known, so finally P2 is found. First we find out the ratio of the total pressure. In terms of this, you know everything, P1T you know P2T. When you know P2T, you know P2 from this equation. So P2 is found out. So when P2 is found out, then you can find out rho 2 from P2 by RT2, and you can find out the mass flow rate. So I am not doing things by putting the numerical value, but I tell you the way. So this value is, you check 5.09 kg, because this will take more time to solve this by putting this value. So that's why I am not doing. So if you put these values, you will get the result. I think there will be absolutely no problem. Now only substitute the numerical value and get the results and check the results with this. Okay. Now next, another problem I will discuss before I leave you. So another problem is this one. Let us consider a problem like this. The following data are suggested as a basis for the design of a single sided centrifugal compressor, single sided. Power input factor is 1.04, slip factor 0.9, almost the similar problem which we discussed earlier. Rotational speed is 290 revolution per second, overall impeller diameter 0.5 meter, I tip, I root diameter. Air mass flow rate is given, inlet stagnation temperature is given, inlet stagnation pressure, isentropic efficiency. Now, what has to be found out? Determine pressure ratio of the compressor, power requirement, inlet angles of impeller vanes at root and tip radii of the eye. Now, let us find out the most simple thing, the pressure ratio. How to find out the pressure ratio? Now, pressure ratio, to find out, what we have to do? Let us again write the pressure ratio formula. If you write the pressure ratio, now I write P3T by P1T is equal to, in terms of the stagnation temperature rise, I think this you know, again and again I am writing. Just now I have discussed this, that the stagnation or total pressure ratio. Here also the pressure ratio of the compressor, total pressure ratio P3T by P1T has to be found out. Now, therefore, what do we require? We require T3T minus T1T. How to find out T3T minus T1T? Again the same formula we know, the work done to the fluid per unit mass or the energy added to the fluid per unit mass, it is psi, power input factor sigma u square, u2 square. Now, this thing can be found out provided psi sigma u2 square is given. What is given in the problem? Let me see. This problem gives rotational speed and overall impeller diameter 290 revolution per second and overall impeller diameter 0.5. So, u2 is equal to pi into the overall diameter 0.5 into 290 is equal to the rotational speed, that means the tangential speed is 4555 meter per second. That means u2 is known. Sigma is given in the problem. If you see, the slip factor is 0.9, sigma is power input factor is 1.04. So, if you put everything, you get the value of T3T minus T1T, which becomes equal to T3T minus T1T is 193K. Here the value of Cp is not given in the problem. If the problem the value of Cp is not given, in any case you can use that for air the value of Cp is 1.005 kilojoule. This is the specific heat per kg K. So, therefore, you can use the value of Cp that and get T3 minus T1T. Eta C is probably given in the, where is eta C? Overall, there is this isentropic efficiency 0.78. When you get the isentropic efficiency 0.78, this is this, T1T is given. T1T is the inlet stagnation temperature, inlet stagnation or total temperature, whatever you call, 295 K. So, everything is known and this P3T equals to, what is the value? Equals to 4.23. This you can check. So, you can find out. So, pressure ratio of the compressor is found. Power requirement is mass flow rate into Cp, this work done per unit mass, T1, either this or this, both the things are same. So, anyway you find out the mass flow rate is given probably, otherwise power cannot be found out, air mass flow rate 9 kg per second. So, work per unit mass into mass flow rate is the power, you know everything. So, power requirement is now 1746 kilowatt. All right. Now, the second part is the inlet angles of impeller vanes at root and tip. Now, at root and tip, if you want to find out the impeller angles, then what will happen? Let us find out and root or tip anywhere at any representative section. It may be root, it may be tip. Okay. That means it may be root or it may be tip, that either it is, this is the root and this is the tip. So, root and tip, axial flow velocity is constant, the normal flow velocity is constant, it is given there. Okay, we will assume that. However, now what happens is that if we know the U1, the rotor speed, and V1 and VR1, if this is this alpha, just I draw the diagram. So tan alpha is U1 by V1. So I have to know the flow velocity or the relative velocity. Tan alpha is V1 by, tan alpha is V1 by U1. So this is, if I know the at root this velocity, then it will be root angle at the root, at the tip it is angle at the tip. Now root and tip U1 will be found out based on the root and tip diameter. That I know because I know the rotational speed, I know the I tip diameter, I know the I root diameter, but here I know neither V1 nor VR1. So how can I find out? So this type of problem is based on a trial. What trial? How to find out V1? So V1 is not known. Now if you see from the mass flow rate basis, mass flow rate is given rho AF V1. Okay, now AF is given. How AF is given? AF is given because I tip diameter and I root diameter is there. So one can find out AF as pi into 0.3 square minus 0.15 square by 4, and this become is equal to 0.053 meters. So I know AF. So I have to, these two I know. So what is that? I have to make a trial. Guess for rho and find out V1. How to guess for rho? This rho, for example, trial 1, this is a trial method, trial 1. I guess rho from the total pressure P1T R T1T at impeller I know T1T, I know P1T. Based on this I find out, and this value is given 1.1 bar into 100 by 0.287 into 295. This is the value given here. Yes, 1.1 bar. So this in terms of kilojoule, this Newton per meter square I am converting. This unit is there. That's why I have written 0.287, which is this value. It should be 10 to the power 5, then another 10 to the power 3, then it will be 287, the characteristic gas constant. You see that consistent unit it is written, and it becomes 1.30 kg per meter cube. Now if you know this rho 1, first trial, this rho 1, trial 1, you put that thing rho 1, and if you know the mass flow rate is known, mass flow rate is already given in the problem. What is the mass flow rate? Mass flow rate is 9 kg per second. You get a value of V1. Now when you get the value of V1, how to iterate? There should be a base on which you will iterate. When you get the value of V1, you can calculate the corresponding temperature, dynamic temperature by V1 Cp. For example, this density you get, from this density you find out the V1. So with this density if you find out the V1, then V1 for one trial will be 131 meter per second. So when you know the V1, then what you do with this V1, you calculate the, for 131 second, V1 square by 2 into 1.005 into 10 to the power 3, the corresponding temperature. So if you know this temperature, you can calculate the static temperature T01 minus this 8.5 K. T01 we know. So therefore we can find out the static temperature, and at the same time we can find out, this is a little laborious calculation I know, but this is usually done in the design, the static pressure as I told you the formula earlier, the static pressure and static total pressure is related to the static temperature and total temperature to the isentropic relation. So I get P1. When I get P1 and T1, I can find out rho 1 as P1 by RT1. That means by guessing a rho based on the stagnation condition, I find out a V. When V is found out, I find out the dynamic equivalent temperature, and with that temperature I can find out the static temperature and the static pressure by isentropic relation. When these two things are known, static pressure and temperature, then rho 1 is P1 by RT. That means rho is getting corrected. With this rho I find out again the corrected velocity. So this way both rho and V, rho 1 and V11, V11 and rho 1 is getting corrected so that we get a converged value. When we have a converged value, then we get V1. When we get the V1, which is constant, the axial velocity of flow throughout the impeller passage is same. That means it is same as at the root and tip. Then what we will do, when we will use the peripheral speed at the root, then we will get the angle of the vane at the root, and at the tip then I will get the angle at the tip. And if you do so, then you will get, I am giving you this value, the V1, converged value of V1 comes out to be 140 meter per second, and U tip, you find out pi into, as the value is given, you check the rotational speed into tip diameter 273 meter per second, and U root is equal to just half, the diameter is half meter per second, and alpha root, that by tan alpha, that formula V1 by U perpendicular by base, V1 by U, it becomes 46 degree, and alpha tip becomes 27 degree. This is 20 minutes in more from where I have taken, this is the value. So there is an iterative process by which you have to do. Okay, thank you.